Page 13, probability. Draw a Venn diagram which represents the sample space U 1, 2, 3, 4, 5, 6 and the set A of prime numbers. Then calculate the probability of rolling a prime number with a dice, blah, blah, blah. Okay, so first we're going to draw a Venn diagram. Venn diagram you may have done a few times in your math careers. Usually they have a rectangle which represents the universal set, represented by U, and then a circle, two circles, or three circles representing sets. And in this case it says set A is the set of prime numbers, and the universal set is the numbers from 1 through 6. So between 1 through 6, which ones are prime numbers? Remember, prime numbers are numbers that don't have factors other than itself and 1. 1, 2, 3, 4 is not, 5. Okay, so that means that inside the circle A, we're going to have 1, 2, 3, and 5. Inside the rectangle U, there's all the numbers 1, 2, 3, 4, 5, 6. 1, 2, 3, 5 are both in U and in A. The other two numbers, 4 and 6, are not in A, but they are in U. So you draw something like that to represent U and A in this case. Then calculate the probability of rolling a prime number with a dice by counting the elements in set A and dividing by the total number of elements. Total number of elements, 6. Elements in set A, 1, 2, 3, 5, that's 4 numbers. Okay, so the probability of rolling a prime number with a dice, with a die is singular, dice is plural, it's 2/3. Write the elements of the complement set A dash, or A prime. So that would be the elements that are not in A, so that would be 4 and 6. So I'm going to put 4, 6. Then write the number of elements in A prime. So that would be 2, right? Because there's a 4, there's a 6, that's 2 numbers. How do you read the following math expressions? First one here is X is an element of set A. This would be A, set A intersect with set B. This would be empty set. This would be number of elements in set A. This would be set A union with set B. So remember, intersect with means it would be anything that's both in set A and set B. Union would be anything that is in set A or in set B or in both. Write two terms to describe the situation where A intersect B is equal to the empty set. Empty set is a set with nothing inside, sometimes drawn like that, sometimes written like that. Let's see, write two terms to describe the sets where the intersection is the empty set, or nothing. So that would be the disjoint sets, will be non-overlapping sets, or mutually exclusive sets. Okay? So those are two ways to describe it. Draw the situation where the intersection of A and B is the empty set as a Venn diagram. This is easy. You have a set A, and you have a set B, and there is no overlap. So it's very clear in a Venn diagram when you have disjoint or mutually exclusive sets. And then, of course, you have elements inside A, you have elements inside B, elements outside A and B, but you have no elements that are common between A and B. And then, of course, if they are not disjoint, you would see an intersection between A and B, and you would see some elements between A and B. Okay? All right. Number 1, let A be the set of all factors of 6. B be the set of all positive even integers less than 11, and the universal set is X such that, this line is such that X is between 1 and 10 inclusive, X is the numbers between 1 and 10, and X is an element of the integers. The script Z means integers. So we got the whole numbers from 1 through 10. That is the universal set in this case. And A is the set of all factors of 6. So let's see. A is, let's see, 1, 2, 3, and 6. B is positive even integers less than 11. So B would be 2, 4, 6, 8, 10. Okay. So let's see. Describe A and B using set notation. Oh, we just did it. I didn't even know they were going to ask that, but I was doing it because we definitely need that. Illustrate A and B on a Venn diagram. Okay. So first thing we're going to draw on a Venn diagram is the rectangle, which is the universal set. Then we're going to draw circles representing set A and B. And inside A and B, we're going to put 1, 2, 3, 6 in A and 2, 4, 6, 8, 10 in B. Let's see if there's anything intersecting there that would be in this region here. 2 is common between both. 6 is common between both, and I think that's it. So we're going to have 2 and 6 in this yellow region here in the middle. 2 and 6. And then in A and B, in the region that's not yellow, we're going to have the other elements which are in A and B but are not shared between A and B. So B, besides 2 and 6, there's 4, 8, and 10. So I'm going to write those 4, 8, and 10. Last of all, inside U, we're going to have the remaining numbers which are neither in A nor B. So what's left? 1, 2, 3, 4, what about 5, 6, 7, 8, 9, 10. Okay. So that was B. Then in C it says, find the number of elements in A. So there are 4 elements in A, 1, 2, 3, and 6. So the number of elements in A is 6. Then it says to find A union B. So A union B would be, let's see, it would be 1, 2, 3, 6, all the elements in A, plus all the elements in B, 2, but I'm not going to repeat any numbers, so 2 is repeated, 4, 6 is repeated, 8, 10. Okay. Then 3. A intersect B. So A intersect B would just be 2 and 6, which are in the yellow region. Okay. Moving down to 3. If A and B are 2 non-disjoint sets, shade the region of a Venn diagram representing A dashed or A prime, A dash intersect B, A union B dashed, A dash intersect B dashed. Okay, and we're doing all of these? Yeah, I guess so. I didn't write anything saying if I should do them all or not. Okay, so non-disjoint sets, so it looks kind of like what we see up above. And so first we're going to color in A dashed. And so remember, this is A and this is B. So if we're going to do A dashed, and I'm going to make this a little bit smaller, and I'm probably also going to copy and paste it, because we're going to use 4 of them, right? Okay? Alright, so this would be A. A dashed would be everything except for the circle A. So I'm trying to color everything except for the circle A. Okay, so that's A dashed. Then A dashed intersect with B Now I'm going to do A dashed. I'm going to do yellow again. Okay. And then I'm going to do B, blue, intersect with B. So do you see that there's a I don't know what you call it, a bitten apple shape? And I'm going to color that green. The bitten apple shape is both not A and B, and it would not include the bite. So that would be A intersect. A dash intersect B. What about A union B dashed? Okay, so B dashed, let's draw B dashed here. B dashed would kind of look like A dashed that we did before. Would be everything except for the circle, B. That's B dashed. And then I'm going to union it with A. So A I'm going to do in blue. And then you can see the intersection is going to be, and I'm going to do the intersection green, because blue and yellow make green. I'm going to do a bitten apple shape here. So that would be the whole thing. So remember I did A in blue, and then I did the union. Oh, wait a second, it's the union. So I'm not going to use green. Well, maybe I'll use green anyway because I already started. So the union of the blue and yellow would be here, here. It would be a shape. Everything that's colored, everything except for the white part, is A union B dashed, right? Okay. Finally, maybe I should do it with this pen here. So it also includes this part, right? Okay. All right, and then the last one, A dash intersect B dash. So that's going to be an interesting shape. A dashed is everything except for the A circle. And B dashed is everything except for the B circle. And then what am I going to do? I'm going to union those two together. I'm going to intersect those two together. So where is the intersect? The intersect is the outside of both. Do you see how the A bit apple is blue and the B bit apple is yellow? So the intersection is actually outside of both. Okay? So that's that one. And that's that one. And that's that one. And that's that one. Okay? I'm going to just color this in just so you understand which part is that one. A dashed is that part. Okay? Alright. And I will move on to the next video now.